Hello everyone, welcome back to my channel. In my previous video, I explained how I built a dog breed classification model. In this video, I'll walk you through how I integrated that model into a complete web application. This project is called DogBreedAI. It is an AI powered web application that detects a dog's breed from an image and generate meaningful information about it. Before jumping into the code, let me explain the overall architecture. The project follows a client server architecture and consists of a trained deep learning model, a Flask backend to handle requests, a frontend built using HTML, Tailwind CSS, and JavaScript, additional feature pages like marketplace, cart, food section, and offline AI chat system powered by Ollama. The complete flow looks like this. The user interacts with the frontend. The frontend sends the request to the Flask backend. The backend passes the data to the ML model for prediction. And the results are then sent back through the backend to the frontend for display. Let's look at the folder structure. The model used in this project is MobileNet v2 Pretrained CNN model, and this is fine-tuned for dog breed classification. The final trained model achieves around 80% accuracy. The backend is built using Flask, while the frontend uses HTML, CSS, and JavaScript, Tailwind CSS. For AI-based text generation, I integrated Ollama with the Phi model running completely offline. So, the entire backend logic is handled inside server.py. This file is responsible for loading the trained model, handling API requests, and returning predictions or AI responses. When the server starts, the trained .keras model is loaded once into the memory. This avoids reloading the model for every request and keeps predictions efficient. I'll come to this file again. Let's look at the flow. Everything starts from home.html, which is the main landing page after login. What happens here? User uploads a dog image. User optionally interact with the AI chat. When a user selects an image, JavaScript immediately does two things. First, it shows image preview using file reader. Second, the image is sent to the backend. This is a post request with multi-part form data because we are sending a file. Now the real intelligence starts in the backend server.py. The Flask server is always running and exposes two main routes, predict and chat. Let me explain both in detail. First, predict. This route handles dog breed prediction. It receives the images. We save it temporarily because Keras expects an image path. Image processing. This matches exactly how the model was trained. And the model returns probabilities for each class and we select the highest one. Labels are loaded from labels.json, mapping class index to the breed name. The information comes from the data.json and includes food habits, diseases, personality, and cost. And all this information is then returned as JSON response to the frontend. Once the frontend receives this JSON response, breed card becomes visible. Confidence is shown. Extra details are populated dynamically. This makes the UI feel smooth and interactive. The second route powers the chat assistant. How it works? User types a message. Frontend sends JSON and Flask forward it to Ollama local API. Ollama runs completely offline and uses a local LLM. Ollama generates response. Backend sends reply back to the frontend. This avoids cloud APIs and keeps the project fully local and privacy friendly. Since this model runs offline, responses may take slightly longer. On the front end, messages are appeared dynamically to the chat window, just like a real chatbot. The flow is very simple. When a user uploads an image, the front end sends the image to a Flask backend. When it is processed and passed to the model predicts the breed and the result is sent back to the front end. And application also includes a login page with temporarily hard-coded credentials, a home page for image upload and prediction. Beyond prediction, the app also includes a marketplace with add to cart functionality. The cart page reads data from the browser's local storage, display selected items with buy and remove options. A dog food section, a offline chatbot using Ollama Phi for breed related queries, about and contact pages. These pages complete the application by providing project context and user interaction, and a logout feature. Logout directs the user back to the login page, completing the navigation flow. I'll show a recorded demo video so you can see the output clearly. If you want the full source code, check the description. Thank you so much for watching. Stay tuned for more videos.